Well, thank you, James, and good afternoon, ladies and gentlemen. I'd like to start out by, first of all, expressing my appreciation to the Heartland Institute for putting on these conferences, and no presentation from me. Yes, we should clap. And no presentation from me would be complete unless I also recommended that viewers and everybody go to the amazing Heartland documents that they did with other groups as well, called Climate Change Reconsidered. Okay, these are 1,000-page documents which include thousands of references that support much of what you've heard at the conference today. Now, environmentalists and politicians and media often tell us that it's not very long from now before wind and solar power will provide a great deal of the world's energy. They tell us that they're already competitive with conventional fuel sources. They say that they will soon be solid, dependable energy sources. As you'll see in my presentation today, nothing could be further from the truth. Wind and solar power are expensive, diffuse, unreliable, and this may surprise you, but I'll show you, environmentally damaging. Now, what's driving the climate scare what's driving the wind and solar power is the climate scare. So let's have a quick look at how much money is going into the climate scare and where it's actually going. This was put out by the Climate Policy Initiative out of San Francisco. And it shows that in the last 2 years, there's been over $1.5 trillion going into climate finance. Okay, now there's probably a good deal more than that, but this is the amount they've tracked. Now, the United Nations in Copenhagen wanted 50% of the money to go to helping people adapt to climate change, because of course, climate changes all the time, and people around the world need help adapting to natural climate change. They wanted the other half to go to stop climate change, which, as we've been hearing today, doesn't make any sense. But in reality, that's not what has happened. What we find, and this is a very complicated graph, I'm just going to point out 2 parts of it, how the actual funding of climate finance has actually progressed. This is the mitigation component. It is actually 18 times more than the adaptation component. In other words, the world is spending 18 times more money as to what might happen in the future based on computer models that don't work than they are spending on helping real people adapt to climate change today. I found in Copenhagen the Africans were furious about this because their people need help adapting to all sorts of natural climate change that happens all the time. Now, we have to ask ourselves, where is this money going, this mitigation money, this supposed drive to stop climate change? Well, as you can see here, the biggest component by far is private renewable energy, 278 billion, as you can see in this chart here. Now, as a consequence of that, the funding that's going into development and investment in renewable energy electricity generation is now more than double that of fossil fuels. The lower 3 bars are renewable energy generation investment. The upper light gray and darker gray bars are fossil fuel. And you can see, as it says here, investment in renewable energy generation more than doubled that of fossil fuel power generation investment in those 2 years. So as a consequence, you would think there would be a huge growth in the real output of wind and solar power. And this is the kind of graph you see, which tends to support that kind of an idea. Wind and solar power are going through the roof, according to a graph like this, which looks very impressive until you compare it with total world energy consumption. Steve Gorham prepared this graph, and he says that he had to artificially enhance the solar to even make it visible. Okay, Steve Gorham, I'll be referencing his book later in this presentation, is the executive director of the Climate Science Coalition of America, and I encourage you to have a look at his book, Outside the Green Box. But he points out that the wind and solar are so small, they do not even account for the increase in world energy consumption per year, okay, which is about equivalent to 1 United Kingdom every year. And wind and solar can't even compensate for that increase. So when people say we're going to see wind and solar become the primary energy source, well, you have to ask, what have they been smoking? Now, that has occurred even despite the fact that we've had all these climate treaties and protocols and all sorts of things. You can see before the UN IPCC was formed, we had about just over 80% of our energy coming from coal, gas, and oil. After the treaties were formed, about the same. And even now, with 300,000 industrial wind turbines around the world, you can see we still have about the same fraction coming from oil, coal, and gas. Now, there are several basic reasons why wind and solar power have not grown faster to become the solution to our energy needs that environmentalists tell us that they will soon be, because the reality is they will never be. First one is that they're low intensity. And again, here's the book I'm recommending from Steve Gorham, Outside the Green Box. It's wonderful. And I did get some of my information directly from there. He shows how low intensity solar actually is. On a clear day at the equator, 1,000 watts per square meter hit the Earth's surface. In the United States and Southern Europe, that's typically about 800 watts per square meter. Now, only about 15% is converted into electricity, and so what you find is that after transmission line losses, a card table size solar panel can power one 100-watt light bulb. And that's, of course, at the time of day when it's giving the most sunlight. I mean, you're going to get nothing at night. Here's a good example of a large solar station. Let's take a look at how big it is, how much power it puts out in comparison with conventional sources. 750,000 solar panels, 1,500 acres, 100 times the size of a typical natural gas plant. So how much does it put out? About 1/10 the amount of output from a medium-sized natural gas plant. So 100 times the area and 1/10 the output. That's what you call a diffuse energy source. And that's not even one of the largest in the world. Look at this one from India, 13,000 acres, my goodness. Steve Gorham actually drew this graph. There was a study done in Switzerland and it was done in Europe. It was done looking at the solar situation in Switzerland and Germany and actually asking the question, how much do these solar panels produce in comparison with the energy it takes to make them, to actually erect them, to maintain them, because you have to clear the snow off, and also to dispose of them afterwards, because they're frequently made with toxic materials. And what they found is that in Switzerland and Germany, they were N-O-N-E, which means negative on net energy. So they didn't even generate enough energy to compensate for the energy they used throughout their whole lifetime. And Steve actually projected this onto North America, where anything above that line, all of my country, is negative on net energy, and positive if you go below that. So you can see our movement to solar doesn't make a great deal of sense. Wind turbines are also very low intensity, 140 meters apart for the big ones, and they have 200 to 250 times the area of a typical conventional power plant to give the same energy output. And I'll give you an example. This is pretty astounding. This is the London Array, the world's largest offshore wind farm. I don't like the term wind farm because it makes them sound benign. Industrial wind facility, I think, is better. Now, let's take a look at how big these are. They look like little toys in this picture here, but they're immense. This is the base of one of them. You can see this is how big they are. And it turns out there's 175 turbines spread over 100 square kilometers, okay? Now, how much energy do they actually put out? 100 square kilometers. And by the way, they're finding recently that the impact on whales may be very devastating. And it's nice to see that some media are picking up on that. I'd like to just read to you a quote from the UK Daily Mail. Researchers at the University of St. Andrews, which is in Scotland, have found that the noise from offshore wind turbines can interfere with a whale's sonar and can, in tragic cases, drive them onto beaches where they often die. So 100 square kilometers is not being very much welcomed by the whales, you can be sure of that. The average output of 233 megawatts, half the output of a typical power plant. okay, for 100 square kilometers. That's what you call diffuse. Wind turbines, there are so many of them in Denmark. They have about one for every 1,000 people. That's 6,000 wind turbines, average output of 1.5 gigawatts. You can walk right from one side of Denmark to the other and never lose sight of a wind turbine. And it could all be replaced, all those black dots are these huge turbines, could be replaced by one conventional power plant. Now, one of the other factors that is actually ignored by many people is the idea that wind and solar power are intermittent. Now, what we have is something called a capacity factor. That is the amount of power that you get from any of these facilities divided by its theoretical output. In other words, if you have a nuclear station that's rated at several thousand megawatts and you get almost that amount out, you're getting almost 100 megawatts. Now, I'm going to zoom in on this graph, and here's Europe, for example. You can see nuclear gets, on average, over the 5 years, 77% of its rated capacity. Solar and wind are down around 18%. Now, I'm most familiar with Canada, so I'm going to zip here over to Canada. We're doing a little better at 26%. And I'm actually going to show you some of the capacity factors that are forecast for Canada. This is being put together by the Independent Electricity System Operator. It's a Crown corporation in Canada. And what you see on the far left is nuclear. You can see in the summer, which is the orange dot, we're getting virtually 100% of what we're supposed to get based on their capacity. Winter, a little less. Wind and solar on the far right, you can see they're very, very low. Okay, and that's because, of course, of the intermittency that we've talked about. Solar power, as I say, is intermittent. 6 hours per day when the sun's at high elevation. And this is the forecast capacity as to what solar power in Ontario, my province, will be over the next 18 months. Because the government has to decide how reliable are these power sources for contributing to our electricity needs at peak demand. And you can see in the wintertime, it's zero. And this next slide sums up one of the major reasons for that, and I won't even comment. This is wind power over the next 18 months. You can see it's a little better. It's most windy in the winter. And its capacity factors are 37 down to about 18.7, 13.7, I should say. But what you see basically is these are not reliable energy sources. You need huge amounts of backup. And it's occurring all across the world, of course. Here's the UK energy demand, and look at wind power. It's going all over the map. What you end up with then is this conclusion. Mr. Rupert Steele, who is the former director of regulations at Scottish Power, he says 30 gigawatts of wind maybe requires 25 gigawatts of backup. In fact, the American environmentalist Robert Kennedy Jr. says that when you build wind power, you're really building natural gas stations because you need the backup. So this is the reality of what we see. The perception is they somehow fall out of the sky magically and they start generating power. The reality is they're in remote locations, require huge long-distance transmission lines. They need backup conventional power, which, as we say, is just about as much as the total capacity of the wind turbines. They need electrical devices or they'll destabilize the grid. So a very different circumstance to what we hear in the press. They're also very expensive. And this might surprise you. Their real costs are unknown. And I'll use Ontario as an example. Robert Lyman, who works with us and also with Friends of Science, he's an energy and economics expert in Canada. He wrote a very good paper for Friends of Science on the renewable subsidies. And he concluded that nobody knows how much it adds up to, because there's subsidies at federal, provincial, municipal, all sorts of levels, and some of these are not even publicized. While they're listed on the webpage for NRCan, they don't have price tags. So nobody really knows what they cost. This is the kind of graph you often see from the government. It shows this, and I'm going to zoom in on one particular part. The black is the average levelized cost of electricity as explained by the government. And you can see that they're saying that onshore wind is comparable in price to hydro, coal, and nuclear. But they're forgetting some major things here, I think somewhat intentionally. They're not including the cost of huge amounts of transmission lines. They're not including the subsidies. They're not including the cost of backup. Well, those are pretty significant. And this particular researcher, he says VRE, which stands for Variable Renewable Energy, and other hidden costs would likely more than double the real costs to society for wind and solar power. And as we'll see in a minute, it could even be a good deal more than that. The United States has made some effort to understand how much is going into subsidies. I won't go through this, but as you can see, it's many billions of dollars. The Energy Information Administration actually shows the increase in costs for new generation facilities. But as explained in this paper here, and you can see the source below, they're not including transmission line costs. They're not including things like backups. And when you actually do a proper analysis, you come up with something more like this. This is very simple, and I encourage people to go to this webpage of the Institute for Energy Research and americapowers.org. They put out a paper which asks the following question: is new wind and solar really competitive with existing conventional sources? And while they didn't include the transmission line costs, they did include the cost of backup. They did include the subsidies in this analysis. And they found that new wind and solar, when you do it properly, is actually more than twice as expensive as these existing power sources. And we've seen this graph before, and it shows very clearly that as you have more and more wind and solar, your electricity prices go through the roof. Here's a Professor Desrochers, Associate Professor at the University of Toronto. He said, electricity systems are complex, and too often policymakers pursue renewable energy sources such as wind and solar power without understanding their true costs. So that is an understatement, to say the least. So governments must reevaluate the real costs and take into account all the costs that are being considered to this point. So wind and solar power are useful sources if you're off the grid, okay? And if you're prepared to pay a huge price for electricity. They're not useful for incorporation into the baseline power grid because of these factors. And this last one, which I'm going to end on describing, they are environmentally destructive. Not only do we have huge amounts of toxic waste put out when they produce solar panels, most of them being produced in China, but we also see, unfortunately with wind turbines, a huge amount of bird and bat kills. And it's interesting that we're having this conference in Spain because the group Save the Eagles International is actually here in Spain, and they do really outstanding work. And Marc Duchamp, who is the head of Save the Eagles International, he actually gave me this information just in the last few days. The Spanish Ornithological Society reviewed carcass counts from 136 monitoring stations across the country, and here was their conclusion. 18,000 wind turbines in Spain are killing between 6 and 18 million bats and birds every year. And sadly, the bats are being killed at twice the rate of birds. The reason being that birds are killed when they're hit by wind turbines. Bats are killed when they're hit, even if they pass near a wind turbine blade, the low pressure bursts a sac in their brain and they die. And this is very damaging to the environment because we see many of these bat species are being driven to extinction by the wind turbines. An average, these are the Altamont Pass. I won't go through this in detail because Christopher mentioned it. 116 golden eagles killed every year. And that would be well over 3,000 destroyed since the wind facility began operating in the 80s. And here are the other statistics. I'll let you just read that. So environmentally benign wind turbines? If you're a conservationist, you should hate these things with a passion because they are deadly for birds and bats. So my conclusion is this. Aside from funding research into improved methods, and we need to have some improvement in solar, wind is a mature technology. We're not going to see any improvement in that. But solar is worth continuing to research. And we should also research storage. But aside from that, governments should cancel all subsidies and financial support to wind and solar power. The whole situation has become ridiculous. where we consider wind and solar somehow holy. No, we have to analyze them properly, and we realize that they are a huge waste of money and very damaging to our society. Thank you very much.